Hello, everybody. My name is Jack. I work at the Web3 Foundation, so we're the entity behind Polkadot. We've contracted about 5 development teams to help build the protocol, and you'll hear from some of them today from Parity Technologies and in chain-safe systems. But I'm going to do a quick introduction of Polkadot. So who here has heard of Polkadot? Is everybody, I hope? Great. So I'm just going to give a brief introduction about the protocol, and then you're going to hear from a bunch of teams that are actually building on it. So as I mentioned, I'm at the Web3 Foundation. We view the space through the Web3 tech stack. So this view is our lens from which we view the space. So how we deploy grants, how we program the Web3 Summit, pretty much how we approach the space. Polkadot is right here. It's just one of the many different protocols in the space, and you're going to be hearing from the libp2p, from networking, the guy behind that today, as well as some of these other things. So let's dive a little bit into Polkadot. So the reason Polkadot exists today, basically Polkadot was conceived about 3 or 4 years ago by Gavin Wood. So he's the co-founder of Ethereum, and Gavin had finished building and writing the code for Ethereum, and was thinking about, okay, how do we take this world computer to the next level so that it's scalable, and that many different blockchains and decentralized systems could speak together as well as a result of that scalability. So he wrote the Polkadot paper at that time, and then it was at Parity Technologies, and kind of the rest we're working on now. So basically the idea was, hey, there's a bunch of different blockchains, all with different features. So you have Zcash, like a privacy chain. You have kind of lightning fast payment chains with either Litecoin or others. You have UTXO, like a value chain, like Bitcoin, right? And they all do different things. You're going to have Internet of Things chains. We're going to hear from a robotics chain later today. So blockchains are being used in a lot of different industries, and they all require different features. But unfortunately, right now, they're unaware of each other's existence. It's like having the internet on with a bunch of different companies, but those intranets can't actually talk to each other, right? So Polkadot is a networking protocol. So a lot of people ask, do people here know the difference between Polkadot and Ethereum? What's the difference, Aiden? Right, exactly. So Ethereum's a smart contracts platform. And there's a lot of people wondering, oh, what's the difference between Ethereum or ETH 2.0 and Polkadot? So Polkadot is a networking protocol. You can build on top of it smart contracts platforms, but it in itself is not a smart contracts platform. So it's not a privacy chain. It's not like Zcash, but you can build Zcash on top of it, or build it so that it's connected to it. So it's a different layer of abstraction. So I just like to say it's a networking protocol, whereas Ethereum is a smart contracts platform. So let's connect all the different blockchains. So how do we get to one global state? So the idea with Bitcoin was that there was one global state upon which all value in this network, everyone knows who owns what value. There's different slots, and you say, I own a slot, this person owns a slot, and we all agree to that, right? But what if we could have a global state, not just for value, but for data, for digital native assets, whatever it is. So one global state that everyone in the world agrees with, hey, it was sunny today. Hey, it was, this person won this election. And everyone agrees, right? Bitcoin's a consensus protocol. It allows everyone to agree on stuff in a distributed way. So what's if we could agree on stuff that wasn't just Bitcoin, but any form of value, any form of data? This value belongs to this person. My name is Jack, and we all agree to that, and it's mathematically guaranteed by this protocol. So Polkadot allows us to get to that one global state in a way where each aspect of the state can talk to each other. So this is where interoperability comes in. So the architecture of Polkadot, I'm actually going to go here. So Polkadot is made up of is one networking protocol with a bunch of different chains on top of it. So because you can add like an Ethereum-like chain on top of it, and it can support up to, say, 80 Ethereum-like chains on top of it. That means you have 80 times the capacity or the throughput as Ethereum. But the interesting thing is not to clone Ethereum or Zcash or something 80 times, it's to have a bunch of different blockchains on top of it, and all with their unique features. So out of the scaling of blockchains, this approach to sharding, which is similar to ETH 2.0, and they shard, except for it's all the same virtual machine, all the same blockchain, whereas Ethereum, with Polkadot, you can the approach to sharding is different blockchains, so what we call heterogeneous. But scaling in this way also allows you to get that interoperability features, because each of the different blockchains are different. They're parallelized, parachains, but they all can support their own throughput and their own transactions. So one of the differences, people ask, what's the difference between Polkadot and Cosmos? Well, currently Cosmos on their roadmap just supports token transfers. So moving, say, different ERC20 Ethereum tokens between contracts. Whereas with Polkadot, we're going to support well, anything actually. So you can, it can be data. Polkadot makes no assumptions as to the packets of information sent between blockchains. So just like the internet doesn't say, hey, you can only do, you can only send packets of this type in this format between nodes in the network. Same with Polkadot. It actually doesn't care if you're transferring. It doesn't care whether it's private transactions, whether it's Internet of Things data, whatever it is. And as I mentioned, we share security in the Polkadot network, which contributes to this one global state. So currently with Bitcoin, in Litecoin and all of these different original blockchains, everyone kind of competes, right, and fights for hashing power in the network. So you're either mining Monero or Zcash, or you're mining Bitcoin, or vice versa. You're not mining all the different blockchains at once. With Polkadot, the idea is we move from a place where you don't have to choose which blockchain that you're validating on. You could actually just contribute to this one global state. So it brings it back to the point of, hey, let's not bifurcate or separate mining power across many different blockchains so that they're all easier to attack and be overwhelmed by a mining farm in China, for example. Whenever the value of these networks goes down, say Litecoin goes down 75% because blockchains are really volatile. Their native assets are volatile. Well, then it's that much easier to attack the network. But if they're all contributing to one global state, ideally, it's a lot more expensive to attack the Polkadot network. So I'm going to get a little bit just to the network architecture just really briefly. So Polkadot uses the most up-to-date technology available for blockchains. So whenever something like Ethereum was built in 2015, not a lot of blockchains relied on, for example, WebAssembly. So WebAssembly is this, it's supported by all the major browsers. It's a way for, in the case of blockchains, for to have blockchain visualized on like your mobile device or your browser, but also, really importantly, it allows for something called on-chain governance. Who here has heard of on-chain governance? Most folks? Okay, so on-chain governance is basically a way to formalize decision-making about a protocol. So WebAssembly allows blockchains to describe themselves. So they're essentially self-aware with WebAssembly, and that allows you to kind of make the steps for saying, hey, this is how you pass a proposal, and this is how you can upgrade the blockchain. And then libp2p, and Rust, which we'll hear more from later today. As I mentioned, it's heterogeneous, scalable, and secure. So I'm going to quickly go through here since we're running out of time. So breaking down Polkadot. Polkadot, it's a little bit complicated system, and there's many different actors, and the network architecture is very unique. So over here, we have the relay chain, which is basically the networking protocol upon which everything else is built. It relays messages or value between all the different parachains. So parachains could be something like Ethereum, it could be something like Zcash, and then Polkadot the Polkadot blockchain, so to speak, is this right here. And there's validators in between taking transactions and growing the relay chain blockchain, adding, bundling them into blocks and agreeing on them. Collators are like validators, but they're for parachains, and then block, of course. So another look of how the architecture looks like. So relay chains on the far left, you have this. It's like a fractal upon which a bunch of different blockchains are built. So whenever the relay chain is expanded, this is what a bunch of different parachains could look like. So this is the networking protocol, and these are the blockchains, like a smart contracts blockchain or something else. This is kind of another abstraction. So in here, you have the relay chain, you have the validators, you have the parachains, and the collators. And some of these ones are bridges. So Polkadot accounts for all past blockchains, so you can add Bitcoin to the Polkadot network. You could add Litecoin to the Polkadot network. You include them through something called a bridge, which means it's not a native parachain. It can still have its own validators, so it doesn't have to get rid of them or make any changes at all, or even opt into the system. Someone else can opt Bitcoin into the system. It doesn't have to be Satoshi or something like that. Same with other blockchains. You can opt them in by building the bridge yourself. Another view. This is kind of Polkadot version 2. So you have up here the relay chain, the fractal. Under here you have the different parachains, and then you can actually do mini Polkadots. So each relay chain, each fractal supports 80 parachains. So that's 80 parachains. But then you can have one on top of another. So that's where the infinite scalability comes from, or the near infinite scalability, is you can have this tree structure and have messages and value bubble up and down the tree so that everything, like it's a cloud of economic activity, everything can speak together. So quickly, where are we now? We're dividing the development into a series of proof of concepts. So similar to with Ethereum, where there was 8 proof of concepts or 9, we'll have a similar amount for Polkadot. We've gone through the first 3. So we have a live blockchain, a live testnet. So if you've checked out the testnet, good for you. You can be a validator, you can be a nominator on it, you can spin up a node today, and it's live. I think like 30 validators, like 80 nodes or something, and like millions of blocks. And then from POC 2 to POC 3, these are just 2 different testnets, there was actually an on-chain vote. So coin holders use their coins to vote on a proposal to upgrade the blockchain. So this was the first in the wild blockchain upgrade. So that's super exciting. People in a decentralized way agreed on the path forward, voted on it, and it's binding. It was implemented. And so now with POC 4, we're introducing the interchain messaging. So like Cosmos released last week, but it's still just a blockchain, a proof of stake blockchain. It actually doesn't have blockchain messaging yet. So there's really no interoperability protocol yet, but we're working on being one of the first ones with POC 4. So that'll include interchain message passing, and that's coming in the next couple months. There's been a lot of progress made on that, and then once that's implemented in the next, say 2 months or so, roughly, that will pretty much be feature complete Polkadot. So we will have achieved the wild ambitions in the white paper that Gavin Wood wrote a couple years ago in just a couple months. And then POC 5 to 7 is simply how many validators, how many parachains. It's kind of playing with optimizing the system so it's super stable and super secure. So there's about 30 teams building on Polkadot today, which we're really excited about. So teams in the Ethereum ecosystem and in EOS ecosystem, et cetera, are now building on multiple chains at once to see, which ones are good for what. So we're really excited to be one of those platforms that these decentralized applications are choosing. So we have things like Ocean, Aragon, and others. So yeah, here's some materials or some links to some materials. Check them out. And if you have any questions, I'm going to be around all day. And thank you so much for listening, and thank you so much for coming to .deSoul. We have a great bunch of presentations after me, so looking forward to to hearing from all the great teams building on Polkadot. Thanks, guys. Next is Aiden from ChainSafe. So ChainSafe, who's heard of ChainSafe systems? Anybody? Okay, so like 5, 10 of you. So ChainSafe is building blockchain infrastructure. And so they're building Ethereum 2.0, which is the next version of Ethereum. They're also building a Polkadot implementation in the Go programming language. So just like Ethereum has Geth in parity, one in Go, one in Rust, ChainSafe is building the Go version for Polkadot, and Parity's building the Rust version for Polkadot. So there'll be it's a multi-client architecture, and ChainSafe is I think 30 or 25 developers, and they're from Toronto, and they won the first Web3 Foundation grant. So Web3 Foundation is giving away grants for teams building on Polkadot. So that's on grants.web3.foundation if you want to check that out too. Does anyone have any questions or anything, I guess, about Polkadot or Web3 Foundation? Okay, good, because there's hardly any time. Yeah, that's true. If you ask questions next time, you get a T-shirt. Okay, great. What's your question? Now's good. Why'd they get ready? Yeah. Okay, so the question is it more of a blockchain that's just trying to connect other blockchains, or is it more of a TCP networking stack that's trying to connect different systems? So, really good question. It's hard to say that it's one or the other. So it is like TCP, in that it's trying to connect different systems. So it's trying to connect Ethereum to Bitcoin and various other systems either built on Polkadot or not built on Polkadot. But it does that through having its own blockchain. So that's the way in which the system agrees on who owns what state. So it takes all the transactions from Bitcoin and from Ethereum and adds them into one, and a bunch of other blockchains, and essentially adds them to one block. So there's one queryable block where people can go, okay, this is the state for all of the different decentralized systems at one time. So it uses a blockchain and a consensus mechanism on top of it to come to a global state for all different decentralized networks. So, it can be connected with Cosmos, it can be connected with a bunch of others, but it does it through a blockchain. So it's kind of, does that answer your question? Yeah, exactly. So the system is supposed to be decentralized through a number of different ways. So there's going to be hundreds and maybe thousands of validators. So it's permissionless in that way. Any decentralized network can opt into the system, so it's a little bit decentralized that way. There'll be multiple clients. Parity's developing client, ChainSafe, a couple other teams, so it'll be decentralized that way. So there's a number of different ways to measure decentralization, and but in the sense that there's one blockchain, I guess, yeah.